Good afternoon. Today we are working on our last objective in this unit. So if this is our last objective, that means that next week is testing time. So tomorrow, we don't have retakes that we have to do. So your job tomorrow is to review on your own this unit, and you're going to be looking at all the objectives from this unit and creating your own help sheet. You're doing it on your own quietly. There will be Khan Academy assigned tomorrow, so you will have that. And we do have our printouts of our math packets. They just need to be stapled. So your job for tomorrow is make your help sheet and review on your own. Work on Khan Academy, and you can look over the math packet. So there will be plenty for you to do in math class tomorrow. It is not social time, not time for us to be talking. Okay, so I'm just making that clear. Back to today's objective. PO45. It is a PO. This is one that we have to have mastered. So PO45 is I can determine the probability of compound events. So we've talked about mutually exclusive. We talked about overlapping. Now we're talking about compound events. So compound events are two or more events occurring. So a compound event is when there are two or more events happening. Compound meaning more than one. So a compound event requires multiple successful outcomes. Everything must happen exactly. So let's say there are 8 red marbles, 5 blue marbles, and 7 white marbles are all in a bag. What is the probability of choosing a red marble, replacing it, then choosing a white marble? How would we go about finding that probability? What do you think, Hugo?
Multiplying.
Think about how did we find probabilities? We weren't multiplying with the probabilities.
Let's multiply the two probabilities together. Divide it.
There are 8 marbles, or 8 red, 5 blue, and 7 white.
You find the probability of the red, then the white, and then you multiply. That's it.
You find the probability of finding. Say that one more time, Hugo.
Find the probability of getting a red marble times the probability of getting a white marble.
Okay, so first thing we're going to do is find the probability of the red marble.
Mm-hmm.
So what is the probability of a red marble? Thinking back, how did we find that probability? Remember, probability is successful over the total. It's really important to remember the difference between probability and odds. Probability is successful over the total. So what's the probability of choosing a red marble? Tatum.
When you do red, 8 divided by divided by 8 plus 5 plus 7.
What is 8 plus 5 plus 7?
20.
So our probability of choosing a red marble is 8 out of 20. We can always simplify and say 2 out of 5. But for this sake, we'll just leave it as the 8 out of 20 because we're not done yet. We don't have to worry about simplifying until we are done. So the probability of choosing the red is 8 out of 20. So now what's the probability of choosing a white marble? We replaced the red, so we know it's still the same number of marbles. So I can put the 20 on the bottom. We know that there's still 20 marbles. What do I put on the top? 7, because there are 7 white marbles in the bag. So I have 8 out of 20 for the red, 7 out of 20 for the white. Now, since this is a compound event, the probability of both events happening is the product of each individual event. So Hugo was right. The product means we multiply each individual event by each other. So The compound event is that 8 out of 20 times 7 out of 20. So you have to multiply that. Remember, when we multiply our fractions, we multiply across the top, multiply across the bottom. And then we're going to turn it into, I added, oh my goodness, it is the end of the day of a very long week for me. Not 8 plus 7, 8 times 7. Be careful. Don't make simple math mistakes.
Okay, you multiply the bottom and you.
So, 56 out of 400. We can simplify that. I am just looking to see if it says how he wants his answer. So, what we're going to do, instead of having to simplify it for this page, we want our answer as a percentage. So we don't have to simplify our fraction. You can just give me the percentage. So 56 divided by 400 would be what percent, Emmett?
14.
Thank you for just Emmett answering, since I called Emmett's name. There were several of us yelling out. Not just him. I heard from several people. So 56 divided by 400 is 14%. So that is the probability of choosing a red marble, replacing it, and then choosing the white marble. There's a 14% chance that that will happen. James.
Yeah, I just got the percentages from the start and just multiply them.
Oh, so you actually, that would work. It's just more steps. So you're doing 8 divided by 20 and getting a percent, and then 7 divided by 20 and then getting a percent, instead of just, yeah. So, I mean, either way works. Remember, there's multiple ways to do math. So, yeah, both ways work. So we did multiplying the fractions to get the total and then get the percent. And what James did was he found the individuals, got their percents, and then multiplied those together. Either way is a valid way of doing it. Let's do another one to make sure we are really understanding what we're doing. Yeah. Shh. Let me erase and scroll up.
Isn't this kind of like the pants and the shorts, like how many possible outfits?
Kind of.
It's kind of like that, except
Kind of, yes.
we're doing probability instead of how many outfits.
Yes. Yes. So, what is the probability of choosing a blue marble, replacing it, then choosing a red marble? So, what are my steps? I need to find each individual event. So, what's the probability of choosing a blue marble?
5 out of 20.
5 out of 20. What's the probability of finding a red marble?
8 out of 20.
8 out of 20. Now we need to multiply those together. And I get that 40 out of 400. What percent would that be?
10.
10%. So, here's the thing when it comes to these word problems. What we know about word problems is you really have to slow yourself down so you can catch when they change things up. We've had a replacing the marble. There's a replacing the marble.
Not replacing.
This one, we're not replacing it. So what does that change? Chance.
You would like minus 1 from whatever marble you take, and then minus 1 from the total.
So it's 9.
So if we're choosing a blue marble, what would that individual event be?
Takes 1 out of bag.
So
Five out of
what's
20.
the probability?
5 out of 20.
5 out of 20. But now I don't replace that blue, so what's my probability for choosing a
But
red
what
marble?
if you didn't? What if you drew a red?
It's 8 out of 19.
Oh, why is it 8 out of 19, James?
Because you took out a marble and you didn't.
So I still have that same number of red marbles, right? I still have 8 red marbles, but now there's not 20 in the bag. Now there's only 19 because I didn't put that blue one back in. So I still have 8 red. I didn't change how many red were in there, but I changed how many total marbles there are. So then I multiply that together. So you really do need to slow your roll with this. You need to make sure that you're reading it correctly to know how many successful outcomes there are, how many total outcomes, and if any of them are changing. Chance.
Do we round our percentage or do we locally round?
So when we're doing a percentage, remember that 10% would be 0.10. We round to the 100th place. So if you're doing a percentage, I don't want to see a decimal in your percent. It wouldn't be 10.2%. Round it to the 100th place for your percent.
I'm just saying if you have like 12.2.
12.25%.
No, it would be 12%. Yeah. Yep. So you round to the 100th place. I think it's time for you to go. Hello, this is Kate. Yep, he's on his way. Thanks. So for my friends at home, we hope you are well, and we hope to see you soon. Have a wonderful day.